So this is Buzz, a new project that's come out by Block by Jack Dorsey, an open source Apache 2 licensed product. Buzz is essentially a shared workspace where humans and AI agents can work together. Meet your starter team. So it gives you 3 agents at the beginning. Let's go to Buzz now. So here we are. Hi, honey. Can you talk to Fizz? Please make this conversation happen visibly in the channel so I can view the conversation you're having. Now, we'll see what happens here because my main concern with all of this is the so-called infinite loop. If you have 2 AI agents in the same channel, in the same chat group, talking to each other, it's possible that they can form a never-ending loop where one agent's response becomes the other agent's prompt, and they just go back and forth. Okay, so look, he's mentioned Fizz, and Fizz has now replied at Honey, so Honey will reply now because Fizz has mentioned Honey. In Buzz, the agents will only talk to each other if they use the @mention sign. Is this never going to finish now? I mean, they're going to keep on responding to each other. And you'll see, and they are still using the @mention. So they are continuously talking here. And I feel we have entered an infinite loop here. I don't see how they would stop or why they would stop. And I mean, in Buzz's own internal documentation, it says it observed a 21 plus reply loop. And because essentially like Buzz is allowing multiple agents to talk to each other. But what Buzz has not really done is implement agent orchestration. There is no orchestration here. There is some prompting rules and some tools that are being called to prevent these so-called infinite loops. But you can see in practice that with a simple prompt like I originally wrote for them to chat, that will just trigger an infinite loop. So let me just show you here a diagram of what is actually happening in terms of orchestration. To have a true agent orchestration, it would need to follow one of these 4 families: central orchestration, which is where you have a central controller, and worker A and worker B are being managed by that central controller. The input is some work request. Or you would have working separately, where you have a shared brief and worker A and worker B are both working from that shared brief, but they're not communicating, and the results get combined. The third pattern is the so-called working together, where worker A and worker B are communicating, and at some point you have a stopping rule where the work stops. Often they have a shared objective. Well, not often, but you have a shared objective which goes into the system, and then worker A and worker B are working together until a stopping rule is met. Or you have indirect coordination, where you have a shared medium, and worker A and worker B are taking work from that shared medium, completing it and reporting back, inputting results back in, updating the shared medium. And there is often some stopping rules so the agents know when they are no longer required to do any work. Now, these four orchestration patterns, these are very broad families, and they're not mutually exclusive. So you can see here, this is the shared objective here. I've addressed it to Honey, have a back and forth, and talk about something. I addressed that to Honey. Honey then addressed a message to Fizz. So what is really happening here, the shared objective was my initial prompt, which went to Honey, here, agent A. Honey then sent a message to agent B, which was Fizz. And Fizz then responds with a message addressed to agent A, which is Honey. And the loop continues. So this orchestration, agent orchestration, is the so-called working together orchestration pattern, which is a very broad pattern. There's a lot of sub-patterns involved in this. I can show you some of these sub-patterns briefly here. If I go to working together here, working together, you'll see there is a load of sub-patterns here. We have a look, Fitboard. All of these here are sub-patterns of working together. So there's various different patterns in that very broad family of working together. So with what we have created in Buzz, with Fuzz talking to Honey, we have no stopping rule, which is why they're not stopping, which is why Buzz hasn't really implemented any kind of agent orchestration. So you're going to hear a lot of, people on X, on YouTube, a lot of the hype train's going to be moving now. And you're going to hear a lot of people saying they've done this agent orchestration. And now because of Buzz, we have real agent orchestration. And we don't have real agent orchestration at all. All they've tried to do is prevent infinite loops. And they haven't actually achieved it because we've just, in our very first prompt, achieved an infinite loop. There is no agent orchestration in Buzz. Well, there's no deep agent orchestration yet. Hopefully they'll put it in, but certainly, there's not. For example, in Buzz, central orchestration can certainly be achieved. I could make a new agent, call him an orchestrator, tell him to do this work, tell him to delegate this work to other agents, and he would literally go off and do that. But there is no underlying orchestration patterns built in to the code base of Buzz, because I've looked, it's open source. You can go in, I've got codecs to go into the code base and actually look at it, and there is no built-in orchestration. So you can see now we have 37 new messages now, along with all the other messages we had previously. They're not stopping these guys. I mean, to be fair to Buzz, Buzz can produce manager worker agent orchestration, but the orchestration is largely performed by the language models through instructions and messaging. Buzz itself primarily provides the communication level. It provides identities and channels and threads, routing, event storage, and agent tools. But it does not appear to make this chief of staff management into a formally enforced manager worker workflow with tasks, states, dependencies, joins, deadlines, deterministic completion conditions. At the moment, that is missing from Buzz. And so if you see the hype train on X or on YouTube, essentially telling you that now we can create our chief of staff and they can orchestrate all our workers, and we now have an army of AI agents and a workforce of agents working autonomously 24/7. Again, this is not happening yet. Like, it didn't really happen with OpenClaw. You have to implement this yourself by using prompts or cron jobs or setting up systems yourself to orchestrate these agents, because it is not built in to Buzz yet. Okay, I mean, I've had Codex look into the actual repo itself. Because it's open source, we're able to look in and see what's really going on here. And what it looks like is the human has sent a work request to the manager agent, and that manager agent will delegate tasks to agent A, get results, task to agent B, get results, and you'll receive a final answer back to the human. And, like Codex says, this looks like orchestration. The human speaks to one manager agent, the manager delegates work to agent A and agent B, they report back to the manager, and the manager report back to the human. Voila, we have it. We've done it. Agent orchestration, AGI achieved. Hype train has left the station. But it's not really what's happened here. See, what Buzz is actually doing is you've got a human message, and then Buzz routes the message, and the manager, which is essentially just an LLM, decides what to do, and it will delegate some to agent A, to some to agent B. See, underneath, Buzz is mainly routing messages between language models. Instructions tell the manager to delegate work, and mentions activate other agents. You see, the managing agent can only delegate to agent A by using the app mention, or to agent B by using the app mention for agent B. And if the LLM just decides not to do it, there's no underlying system within Buzz to prevent that. But you can see we have limitations here. See, Buzz does not necessarily enforce that both agents receive a task. It's the LLM choosing that. The LLM may choose not to send tasks to agent B, for example, and just send everything to agent A, because there is no underlying orchestration system built into Buzz. And I'm not saying Buzz is a waste of time. Buzz is fantastic. This is the future. Totally agree with what they're doing, but I'm just trying to give you an actual heads up of what's really going on here. And, Buzz doesn't necessarily enforce that the manager will wait for both results to come back, or that the failed work is retried, that the results are checked, or the conversation eventually stops. See, Buzz makes it feel like orchestration, but much of the orchestration exists in the agent-written instruction. Buzz is simply transporting messages, and the language models are trusted to manage the process correctly, which they may or may not do. For a very simple orchestration where you've just got an orchestrator delegating work to some sub-agents and then getting the work returned according to the human, the orchestration will probably work. But once you build very complex orchestration patterns, it is highly likely that it will break down and won't work as expected. See, Buzz does have routing rules and a workflow engine, but this particular chief of staff demonstration is primarily prompt-driven orchestration rather than formally enforced manager and worker workflow by Buzz itself. Agent A might respond, causing the manager to answer the human before agent B is finished. Agent B might fail silently. An agent might forget to mention the manager, or the agent might continue triggering one another. Buzz provides the conversation, but it does not automatically guarantee that the job has been correctly. See, back in Buzz now, how do I even stop this? We've got 67 new messages, 68. It's getting out of hand. Let's see if we can actually stop this. Let's just send a message. Please stop your conversation. Let's see if that works. I think we can assume now that it's been 10 minutes. So that did stop the conversation. So let's create a new channel. So let's click on here, create new channel, and we'll call it Orchestration Demo. We'll make it private, create channel. Let's create a new agent and we'll name him Manager. And we'll give him the instructions that you are the manager. I'll give you a task, delegate one part to agent A and another to agent B. Wait for both agents to report back before giving me one concise final answer. Do not complete their work yourself. Do not send unnecessary acknowledgements. And we're just going to open the advanced. Who can talk to this agent? Only me. I'm going to change that to anyone. Okay, we're now going to create agent A, create new agent, agent A, give him some instructions. You are a critical reviewer. Complete tasks delegated to you by a manager. Look for risks, limitations, and conflicting evidence. Report your findings back to manager. Do not delegate the work and Do not send unnecessary acknowledgement. And again, we're going to go into advanced. I'm going to say, talk to him. And let's create agent B. Agent B will be a researcher. Complete tasks delegated to you by manager. Report your findings back to manager with evidence. Do not delegate work to other agents and do not send unnecessary acknowledgements. And again, in the advanced, select who can talk to this agent. Anyone. Okay, we are in this channel, orchestration demo. We're going to click on agents now. And here you'll see the list of agents we have and the agent teams. And we're going to create a new team and we will just call this team orchestration demo with a description, a manager with 2 specialist workers, and with team instructions. The manager delegates work to agent B, agent A and agent B. Agent A and agent B report their results to manager. Manager waits for both agents before replying to the human. And we will select in this team agent A, agent B, and the manager. I then click create team. And here you can see we have this new orchestration demo team here. So let's just return to the orchestration demo. We're going to send this prompt now to the manager. Investigate whether Buzz is really a Slack replacement. Ask agent B to examine its workplace communication. Ask agent A to examine its developer and GitHub focus features. Wait for both results and then give one short conclusion. So let's send that. Okay, here's the thread. So you can see here that the manager is talking to agent B. Examine Buzz as a Slack replacement specifically through its workplace communication features. Report the strongest capabilities, important gaps, and a brief verdict here with one concrete evidence. And it's sending a prompt to agent A. Examine Buzz as a Slack replacement specifically through its developer and GitHub focus features. Here, agent A has now reported back to the manager. Agent B has reported back to the manager as well. And you would assume now that the manager will now report back to me with the findings. Here we are. Manager has reported back to me. So there we have it. And we would assume now that process would stop and we're not going to get any more response. So what we have seen there is a central orchestration pattern, which was created via a prompt rather than any kind of underlying orchestration infrastructure within Buzz itself. The work request, my prompt, created the orchestration. And the controller, we labeled him manager. And the prompt told the manager to delegate work to worker A and worker B, and then to return that work, the manager returns the work back to me. However, the underlying system in Buzz, it didn't really know that the manager was a manager. We just labeled him as a manager, so it appeared that he was, but there was no underlying orchestration system that really said this manager is a manager and his task is to delegate work to worker A and worker B. And it did work. It's a very simple pattern, this. Work request to the manager, manager to worker A to worker B and worker A go back to the manager who comes back to me. Very simple orchestration pattern. So, it's not really surprising that this orchestration pattern worked. But if you had a very complex orchestration pattern, say you had an orchestration pattern like this, for example, and it becomes very complex with a lot of nodes, a lot of different things that could happen depending on the state of the work at that particular point, whether requests are predefined workflows or manager-controlled workflows, whether there needs to be routing decisions, whether there needs to be checker nodes, decision gates, human approvals. You can see here that you might guess that you might run into some issues setting up a complex orchestration system within Buzz. So one thing that did initially confuse me was how multiple people on different computers can share the same Buzz community. The desktop application alone cannot do that. Every person's Buzz application connects over the internet to the same Buzz relay, and that relay is a shared backend. So when I send a message, my computer signs it and sends it to that relay, and the relay stores it and distributes it to the other humans and agents connected to that community. The agents themselves may run on different people's computers, but they can still communicate because they all connect to the same relay. Underneath this, Buzz uses a database to store messages and other events. It can also use object storage for files and media. So Buzz is not purely peer-to-peer application where everybody's computer somehow communicates without a server. Somebody has to host and operate that shared infrastructure. There are now 2 ways of doing that. So a company can self-host it, but then it must deploy, secure, update, and back up the relay. Buzz also offers block-hosted communities through Builder Lab using addresses, including using addresses ending in communities.buzz.xyz. So Buzz does have both backend and hosted options. The real question is how mature those hosted services are and what it will cost, where the company data is stored, what guarantees and administration, compliance and recovery controls does that provide. Buzz has built-in technology for humans and agents to collaborate. It has not yet demonstrated the mature managed business service that Slack provides.